Here's a detailed explanation of what the internet is and how it works, broken down into clear sections. What is the internet? The internet is a global system of interconnected computer networks. It uses standard communication protocols to allow devices across the world to communicate and share information. It's not a single machine or a place. Instead, it's a vast infrastructure made up of cables and satellites, routers and switches, data centers and servers, end-user devices like computers and smartphones. The internet enables services like the World Wide Web, WWW, email, file transfers, FTP, online messaging and video calls, streaming services like YouTube, Netflix. Key concepts behind the internet. 1. Network of networks. The internet is essentially a network of smaller networks. These include home and business networks, government and educational networks, data centers and cloud providers. All of these networks are connected using Internet protocols, IP. 2. IP addresses. Each device on the internet has a unique IP address, like 192.0.2.1, which is like its digital home address. IPv4, e.g. 192.168.11, and IPv6, e.g. 2001 AeroDB8 85A3, 8A2E03707334, are two types of IP addresses. These help identify where data should be sent and received. 3. Domain Name System, DNS. Humans use domain names, like .google.com, but computers use IP addresses. The DNS acts like the internet's phone book. You type a domain name. DNS translates it into the IP address of the server where the website is hosted. Number 4, Internet Service Providers, ISPs. To connect to the internet, you need an ISP such as Airtel, Jio, or BSNL. ISPs provide you with a connection to the wider internet. Route your data to its destination. Number 5, protocols that make the internet work. TCP/IP, Transmission Control Protocol, Internet Protocol, responsible for breaking data into packets, sending them, and reassembling them. HTTP/HTTPS, Hypertext Transfer Protocol, used for web communication. FTP, File Transfer Protocol, used to upload/download files. SMTP/IMAP, Simple Mail Transfer Protocol, Internet Message Access Protocol, used for sending/receiving email. How the internet works, step by step. 1. You make a request. Let's say you type www.youtube.com into your browser. 2. DNS resolves the domain name. Your device contacts a DNS server to find the IP address of www.youtube.com. DNS returns something like 142.250.99.206. Hash and her premise. 3. Data packets travel across the internet. Your browser sends a request to the YouTube server's IP address. The request is broken into packets and sent through your router, your ISP, multiple routers and switches, often called the internet backbone. Packets may take different routes, but will be reassembled when they reach the destination. 4. The server responds. YouTube's server processes the request. It sends back data, HTML, JavaScript, images, video stream to your IP address. 5. You receive and view the data. Your browser takes the data, interprets it, and renders the web page or video. Infrastructure of the internet. Routers and switches. Direct traffic between networks. Data centers. Store websites, apps, and services. Cables. Fiber optic and copper cables carry data worldwide. Satellites and wireless towers enable communication in remote areas. Internet security encryption. To keep data safe, HTTPS with SSL/TLS encrypts data sent between your browser and websites. Firewalls and antivirus software protect your device. Summary table. Component, purpose. IP address identifies devices on the network. DNS translates domain names to IP addresses, connects your device to the internet. TCP/IP sends data in packets. HTTP/HTTPS used for loading web pages. Web server hosts websites and services. Browser displays website content. Track example flow. Visiting Google. 1. You type www.google.com. 2. DNS returns Google's IP address. 3. Your browser sends a request to that IP. 4. Google's server sends back the search page. 5. You see the page in your browser. Here's a detailed explanation of HTTP and HTTPS protocols, including how they work, their differences, and why HTTPS is essential today. Introduction to HTTP and HTTPS. What is HTTP? HTTP stands for Hypertext Transfer Protocol. It is the foundation of data communication on the World Wide Web, WWW. It defines how messages are formatted, sent, and received between a client, like a web browser, and a SHAR server, where websites are hosted. Introduced in 1991 as part of the early web, works over port 80 by default, used to load websites, submit forms, fetch data, etc. What is HTTPS? HTTPS stands for Hypertext Transfer Protocol Secure. It is the secure version of HTTP. It uses encryption to protect data transmitted between the client and the server using SSL TLS, Secure Sockets Layer, Transport Layer Security, works over port 443, encrypts data to ensure confidentiality, integrity, and authenticity, used on all modern websites to secure login forms, payments, and sensitive data. How HTTP works. Step by step 1. You enter a URL, example http://example.com. 2. DNS resolves domain, gets the IP address of example.com. 3. Client sends request. The browser sends an HTTP request to the server, get index.html http 1.1 host example.com. 4. Server responds. The server replies with an HTTP response, http 1.1 200 OK, content type text HTML, content length 1024, followed by the HTML content. 5. Browser renders web page. It displays the website on your screen. How HTTPS works step by step. 1. You visit an HTTPS website. Example, https://example.com. 2. TLS handshake. Before exchanging actual data, the browser and server. Exchange certificates. Negotiate encryption algorithms. Generate a secure key. 3. Secure communication established. All further communication is encrypted. The user sees a padlock icon in the browser. 4. HTTP request sent over secure channel. Just like HTTP, but encrypted. Prevents eavesdropping or tampering. Key differences between HTTP and HTTPS. Feature: HTTP, HTTPS, full form, Hypertext Transfer Protocol, Hypertext Transfer Protocol Secure, port 80, 440, unencrypted, encrypted with SSL TLS, URL prefix HTTPS. Data protection, none. Data authentication, no server validation, server identity verified via SSL certificate. Used for non-sensitive websites, secure transactions, logins, payments. Why HTTPS is important. 1. Data encryption. Prevents attackers from reading user information like passwords, credit card numbers, etc. 2. Authentication. Ensures you're communicating with the real website, not a fake one. 3. Data integrity. Protects data from being modified during transmission. 4. SEO boost. Google gives ranking preference to HTTPS-enabled sites. 5. User trust. Browsers warn users about not secure sites without HTTPS. Example, HTTP versus HTTPS. HTTP request, plain. HTTP get they want one host, example.com, authorization password 123. This can be intercepted by hackers. HTTPS requested. HTTPS encrypted data. This is encrypted and unreadable to anyone intercepting it. HTTP versions overview. Version description. HTTP 1.1, most widely used persistent connections. HTTP 2, faster performance, multiplexing. HTTP's quick instead of TTP, even faster and more secure. Summary. HTTP is the standard protocol for accessing web pages. HTTPS is the secure encrypted version that protects your data. Always prefer HTTPS for any sensitive operations like login, payments, or private communication. Would you like a visual diagram? Here's a detailed explanation of HTTP and HTTPS protocols, including how they work, their differences, and why HTTPS is essential today, how websites are rendered in web browsers, step by step, from the moment you type a URL to when you see a fully loaded web page. What does rendering a website mean? Rendering refers to the process by which a web browser takes the HTML, CSS, and JavaScript code received from a server and converts it into the visual web page you see on your screen. Step-by-step process. How websites are rendered in browsers. 1. URL input and DNS resolution. You enter a website address like https://www.example.com. The browser uses the DNS domain name system to convert the domain name to an IP address, e.g. 142.258.19.206. 2. HTTP/HTTPS request sent. The browser sends a request to the server using either HTTP or HTTPS. This request asks for the main HTML file of the page. 3. Server responds with HTML. The server sends back an HTML document. The browser starts parsing the HTML immediately without waiting for the whole file to download. 4. HTML parsing and DOM construction. The browser reads the HTML line by line. It creates the DOM, document object model, a tree-like structure that represents all elements like div, p, img, etc. 5. CSS parsing and style calculation. If the HTML includes links to CSS files, link tags, the browser sends requests to fetch them. Once received, it parses the CSS and builds the CSS OM, CSS object model. Then, it combines the DOM plus CSSOM to compute styles for each element. 6. JavaScript execution. If there are script tags, internal or external, the browser downloads and executes the JavaScript. JavaScript can modify the DOM, e.g. insert new elements, react to user actions, clicks, scrolls, fetch more data from the server, AJAX, fetch API. Note, JS execution can pause rendering, especially synchronous scripts in head. 7. Render tree construction. The browser builds a render tree from the DOM and CSSM. This tree includes only visible content, elements that will appear on screen. It calculates layout, position and size of each element, paint, colors, fonts, borders, compositing, layering elements. 8. Painting on screen, rendering. The browser takes the render tree and starts painting elements pixel by pixel onto the screen. This is the actual rendering. This process is handled by the browser engine, like Blink in Chrome, Gecko in Firefox. 9. Handling events. After rendering, the browser continuously listens for mouse and keyboard events, JavaScript changes, scroll or resize actions. It can repaint or reflow the page in response. Summary table, stage, description. 1. URL input. DNS resolves domain to IP address. 2. Request. Browser requests HTML from server. 3. Response. Server sends back HTML. 4. Parsing. HTML DOM, CSS, CSM. 5. JavaScript. Fun. Runs and modifies DOM CSS. Render tree. Combines DOM CSSOM for layout. 7. Painting. Draws elements pixel by pixel. 8. Interactivity. Listens to user actions and updates view. Key browser components involved. Component purpose. Networking. Handles HTTP, HTTPS, downloads resources. HTML parser builds the DOM. CSS parser builds the CSSOM. JavaScript executes JS, e.g. V8 in Chrome. Render engine constructs render tree and paints UI. UI backend draws widgets, fonts, images. Compositor handles layers and animations. Pro tip, critical rendering path. The critical rendering path is the sequence of steps browsers take to convert HTML, CSS, and JS into pixels on the screen. Optimizing it improves performance and load speed. Example, simplified. You visit https://example.com. 1. Browser asks DNS, gets IP. 2. Sends HTTP request, gets HTML3. Parses HTML, builds DOM. 4. Downloads CSS, builds CSSM. 5. Downloads and runs JS. 6. Builds render tree. 7. Paints content on screen. 8. User interacts, browser responds. Would you like a visual diagram how websites are rendered in web browsers? Step by step. From the moment you type a URL to when you see a fully loaded web page. Here's a detailed explanation of the fundamentals of client and server interaction, one of the core concepts in web and network communication. What is client-server interaction? The client-server model is a computing structure that splits tasks between a client, which requests data or services, a server, which provides responses or performs services. This model is foundational to how the internet, web applications, and many software systems operate. Who is the client? The client is typically a web browser like Chrome, Firefox, Safari, a mobile app, or even a desktop application. Main role: send requests to servers and display or use the returned data. Who is the server? The server is a remote machine, could be physical or cloud-based, runs specialized software to listen for incoming requests, sends back data or services upon request. Main role: wait for client requests, process them, and send responses. How client-server interaction works. Step by step. 1. Client sends a request. The client initiates communication. For example, getindex.html is a request from a browser to retrieve a homepage. This is usually done using HTTP or HTTPS protocols. Number 2, server receives the request. The server listens on a specific port, usually port 80 for HTTP, 443 for HTTPS. The server receives the request and starts processing it. Hammer 3, server processes the request. It determines what is being asked, e.g. a file, data from a database. Executes code like PHP, Node.js, Python if needed. May query a database or other systems. Hammer 4, server sends a response. The server sends back data, usually as HTML, CSS, JS files, JSON for APIs, images, videos, or documents. The response includes a status code, e.g. 200 OK, 404 not found. Hammer 5, client receives and processes response. The browser app renders the content or uses it in some way. If needed, it can send more requests. Protocols used in client-server communication, protocol purpose. HTTP, HTTPS, used for websites and APIs. FTP, used for transferring files. SMTP, IMAP, POP3, used for sending, receiving emails. WebSocket for real-time two-way communication. Example, loading a web page, client-server flow. 1. User types www.example.com in the browser. 2. Browser sends a GET request to the server. 3. Server returns index.html. 4. Browser makes more requests for CSS, JSS, and images. 5. Server responds with each file. 6. Browser displays the page to the user. Key terminology, term description. Request, data sent by the client to ask for something. Response, data sent back from the server. Status code indicates success, 200, error, 404, etc. API, application programming interface for structured data exchange. Stateless, each request is treated independently by the server, e.g. HTTP is stateless. Method, purpose, retrieve data, repost, submit data, update data, delete, remove data. Summary table, role, what it does, client sends requests and displays, uses responses. Server, listens, processes requests, returns results. Request, initiated by client, response, returned by server. Vercel real-world analogy. Think of a restaurant. Client equals you placing an order, server, waiter, taking your order to the kitchen and bringing food back. Kitchen equals backend systems databases. Menu, API, list of what you can request. Would you like a diagram? Here's a detailed explanation of the fundamentals of client and server interaction, one of the core concepts in web and network communication. How the front end and back end communicate, a key concept in full stack development and web applications. What is front end and back end? Front end, client side. The front end is the part of a web application that the user interacts with directly, built with HTML, CSS, JavaScript, runs in web browsers. Role displays the UI and collects user input. Backend, server side. The backend is the behind-the-scenes part that handles business logic, database operations, and security, built with Node.js, Python, PHP, Java, etc. Runs on web servers. Role processes data, performs computations, interacts with databases. How do front-end and back-end communicate? They communicate using HTTP requests and responses, usually over REST APIs or GraphQL APIs. Step-by-step workflow. 1. User triggers an action on the front end. Example, a user clicks login on a web page. Front-end code collects user input like email and password. 2. Front-end sends an HTTP request to backend, sends data via AJAX using fetch or Axios, sends it to a specific API endpoint on the backend. JS fetch api.example.com, method post, headers, content type application/JSON, body JSON.stringify, email, password. Number 3, backend receives and processes the request. Backend verifies credentials, maybe with a database lookup, performs logic like authentication, data validation, etc. Hammer 4, backend sends a response, sends back a response object, typically in JSON format. JSON success true, token, ABC123XYZ. Hammer 5, frontend processes the response. If successful, saves a session token, redirects the user, or shows data. If error, shows validation errors to the user. Data format for communication. The frontend and backend often communicate using JSON, JavaScript object notation, Most common XML, less common today, form-encoded data for legacy systems. Key terminology, term, description. API, a set of defined rules that allow the front end to interact with the back end. Endpoint, a specific URL on the back end that performs a function, e.g. /login. HTTP methods, get, post, put, delete for different types of requests. AJAX, technology used by frontend to send requests without reloading the page. CORS, security rule that controls cross-origin requests between frontend and backend. Example in a real JS, JS use effect equals fetch hpsi.example.com has JSON, then data, set posts data. Backend, Node.js with Express, JS app.get/posts recres, const posts id1 hello world, rest.json posts. Authentication and security. Frontend often sends JWT tokens and headers, authorization bearer token, cookies for session management. Backend uses middleware to validate and authorize the request. Summary table step frontend, backend. 1. Collect user input, waits for HTTP request. 2. Sends HTTP request, parses input. 3. Waits for response, queries DB, applies logic. 4. Renders result or shows error, sends JSON response. How the front end and back end communicate, a key concept in full stack development and web applications. Here's a detailed explanation of the overview of APIs and data exchange, breaking down what APIs are, how they enable communication between systems, and how data is exchanged. Overview of APIs and data exchange. Detailed explanation. What is an API? API stands for Application Programming Interface. It's a set of rules and protocols that allow two software systems to communicate with each other. Think of an API as a waiter in a restaurant. You, the client, order food. The waiter, API, takes the order to the kitchen, server. The kitchen prepares the food. The waiter returns the food, response to you. Why APIs are important. Enable system integration. E.g., a weather app fetching data from a weather API, standardize communication between front-end and back-end, allow third-party apps to access functionality like Google Maps or payment gateways, support microservices architecture, independent services communicating via APIs. Hash how data exchange happens via APIs. 1. Client sends a request, usually through HTTP/HTTPS, common methods get, post, put, delete. Example, HTTP guy users 1, HTTP 1.1 host, api.example.com. Hash 2, API processes the request. API checks, request method, headers, authentication if needed. Then it retrieves data from a database, performs logic or computation, prepares a response. 3, server sends a response. Server responds with status code, e.g. 200 OK, 404 not found, data format, commonly JSON or XML. Example response, JSON ID 1, name, John Doe, email, john@example.com. Common API formats, format description. JSON, lightweight, human-readable data format most common. XML, older structured markup format. GraphQL, flexible query format, alternative to REST. Form data, used in file uploads or form submissions. Types of APIs, type description. Example, REST API, standard web APIs using HTTP, GET, API/products. SOAP API, XML-based, used in enterprise systems, WSDL files. GraphQL API allows specific data querying, query username. WebSocket API enables real-time communication, live chat, stock updates. Security in API communication. Authentication, API keys, OAuth tokens, JWT, JSON Web Tokens. HTTPS, ensures encrypted data exchange. CORS, cross-origin resource sharing. TA restricts which domains can access the API. Diagram of API data flow, text, client, app pretend. Send request, get, post, etc. API server, process, query DB, run logic, send JSON XML response, displays or uses data. Now real-world examples. App feature API in action. Google Maps, calls Maps API to get routes. Weather app, fetches weather data from an API. Login with Google, uses OAuth via Google's API. E-commerce checkout, payment API, Stripe, Razorpay. Summary. APIs are essential bridges between systems. They allow structured, secure data exchange. APIs are used in almost every digital product today. websites, mobile apps, cloud services. REST and JSON are the most commonly used methods. Would you like a visual infographic? Here's a detailed explanation of the overview of APIs and data exchange, breaking down what APIs are, how they enable communication between systems, and how data is exchanged. Full-stack development refers to the end-to-end development of both the front-end client-side and back-end server-side of a web application. A full-stack developer is someone who can build entire web applications and websites, including designing the front-end interfaces, writing back-end logic, handling databases, APIs, and deployment. Full-stack development. Detailed explanation. Full-stack development refers to the end-to-end development of both the front-end client-side and back-end server-side of a web application. A full-stack developer is someone who can build entire web applications and websites, including designing the front-end interfaces, writing back-end logic, handling databases, APIs, and deployment. Components of full-stack development. 1. Front-end development, client-side. This is what users see and interact with directly in their web browser. Technologies. HTML, structure of the web page. CSS, styling the content. JavaScript, adds interactivity. Front-end frameworks libraries. React.js, Vue.js, Angular. Responsibilities. Creating responsive designs, implementing UI/UX designs, handling browser-side routing, consuming APIs, and displaying dynamic data. 2. Backend development, server-side. Handles the logic, database operations, and API integrations behind the scenes. Technologies, languages, Node.js, JavaScript, Python, Ruby, PHP, Java, etc. Frameworks, Express.js, Django, Laravel, Spring, etc. Responsibilities, handling business logic, managing user authentication and authorization, connecting to and managing the database, creating and managing APIs, server configuration and file handling. 3. Database, stores and manages all application data. Types, relational databases, SQL, MySQL, PostgreSQL, non-relational databases, NoSQL, MongoDB, Firebase. Responsibilities, data storage and retrieval, schema design, query optimization, data relationships, in SQL. 4. Version control, tracks changes in code and collaborates with teams. Tools, Git, GitHub, GitLab, Bitbucket. 5. Deployment and DevOps, putting the application live on the internet. Responsibilities, web hosting and domain setup. CI/CD, continuous integration, continuous deployment. Load balancing, scaling, monitoring and performance optimization. Platforms, Vercel, Netlify, front-end hosting. Heroku, Render, AWS, DigitalOcean, full stack. Docker and Kubernetes for containerization. Example full stack tech stack. MERN, MERN equals MongoDB plus Express.js, React.js plus Node.js. MongoDB, NoSQL database. Express.js, backend framework. React.js, front-end library. Backend runtime environment. How full-stack development works together. User, front-end, Rand Express node, database, MongoDB. Example use case, blog application, layer description. Front-end shows blog posts. Lets user create, edit, delete posts. Handles post requests, manages users, validates data. Database, stores user data and blog post content. Why learn full-stack development? Build complete apps independently. Better job opportunities. Full-stack developers are in demand. Understand the entire product lifecycle. Increased collaboration between front-end and back-end teams. Essential skills for full-stack developers. Category: skills, GitHub via frontend, HTML, CSS, JavaScript, React, Vue. Backend, Node.js, Express, Python, Django. Databases, MongoDB, MySQL, PostgreSQL. Dev tools, Git, GitHub, deployment. Vercel, Heroku, Netlify, Docker. Soft skills, problem solving, communication, agile. Hair visual diagram, full stack architecture, browser, frontend, HTML, CSS, JavaScript, backend, Node.js plus Express.js. Database, MongoDB, MySQL. # summary. Full stack development equals frontend plus backend plus database deployment. You can build complete web applications on your own. Popular stacks include MERN, MEAN, LAMP, and Jamstack. It's one of the most in-demand skill sets in web development today. Full stack development. Detailed explanation. Full stack development refers to the end-to-end development of both the front-end client side and back-end server side of a web application. A full stack developer is someone who can build entire web applications and websites, including designing the front-end interfaces, writing back-end logic, handling databases, APIs, and deployment. Here is a visual diagram showing how the front-end, back-end, and database components interact in a typical web application. Here's a detailed explanation of the components of a web application: front-end, back-end, and database, including how they work together. Number 1, front-end, client side. What is it? The front end is the part of the application that users interact with directly. It runs in the web browser and includes all the visual elements, such as buttons, forms, pages, and styles. Technologies used: HTML, structure of the page; CSS, styling and layout; JavaScript, interactivity and logic; frameworks, libraries, optional but common; React, Vue, or Angular; Bootstrap, Tailwind, CSS for styling. Role in a web app: displays content and interface, sends requests to backend, e.g. to get data or submit a form, updates UI dynamically based on user actions or responses. Example: on an e-commerce site, the front end shows the product listings, handles filtering, and allows you to add products to your cart. Number 2, backend, server side. What is it? The backend is the part of the application that runs on a server and handles business logic, authentication, authorization, and communication with the database. It processes requests from the front end and returns responses. Technologies used: languages: JavaScript, Node.js, Python, Django, Flask, Java Spring, PHP, Ruby, etc. Frameworks: Express.js, Django, Laravel, etc. APIs: RESTful APIs, GraphQL, WebSockets. Role in a web app: receives front-end requests, e.g. login, fetch data, validates and processes data, connects to the database to read-write data, sends data back to the front end. Example: if you log into a site, the backend checks your credentials, creates a session token, and responds with authentication status. 3. Database. What is it? The database is used to store, organize, and retrieve data for the application. It keeps all the persistent data, such as user accounts, posts, products, transactions, etc. Types of databases: relational SQL, structured and table-based. Examples: MySQL, PostgreSQLite. Non-relational, NoSQL, flexible schemas, document or key value based. Examples: MongoDB, Firebase, Redis. Role in a web app: stores data for long-term use, allows querying, inserting, updating, and deleting data. Works with backend to serve or save data. Example: when you register on a website, your name, email, back, and password hash are stored in the database. Hack how they work together. Flow example: you can see the code in our conversation history. Step by step. 1. User fills out a form on the front end, e.g. create account. 2. Front end sends the form data to the back end via an HTTP post request. 3. Backend validates the data and sends a query to the database to store it. 4. Database saves the data and sends a success message back to the backend. 5. Backend sends a response, e.g. account created, back to the front end. 6. Front end updates the UI, e.g. redirects to login page. Summary table: component, role, technologies, bound 10. Front end, user interface and interactivity, HTML, CSS, JavaScript, React, etc. Backend, logic, authentication, API handling, Node.js, Express, Django, etc. Database, data storage and retrieval, MongoDB, MySQL, PostgreSQL, etc. Here is a visual diagram showing how the front-end, back-end, and database components interact in a typical web application. Here's a detailed explanation of the components of a web application: front-end, back-end, and database, including how they work together. In a typical full-stack application, technologies span across 3 main layers. 1. Front-end, client side. 2. Back-end, server side. 3. Database, data storage. Let's break down each of these with detailed explanations and popular technologies. Front-end technologies. The front end is what the user sees and interacts with in a web browser. It's responsible for UI, UX, layout, navigation, animations, and data rendering. Core technologies: HTML, hypertext markup language, structure of web pages; CSS, cascading style sheets, styling and layout; JavaScript, interactivity, DOM manipulation, AJAX, etc. Popular frameworks and libraries: React.js, component-based library by Meta; Angular, full-fledged framework by Google; Vue.js, lightweight, flexible JavaScript framework; Tailwind CSS Bootstrap, utility-first CSS frameworks for responsive design. Build tools, Webpack, Vite, Parcel, bundlers to optimize and compile assets. Babel transpiles modern JavaScript to compatible versions. Version control, Git and GitHub GitLab Bitbucket, track code changes and collaborate. Number 2, backend technologies, server-side. The backend handles the logic, authentication, authorization, data processing, and API responses. It powers the front end with dynamic data. Programming languages, JavaScript, Node.js, popular for JavaScript full stack. Python, Django, Flask, easy syntax, great for APIs. Java, Spring Boot, scalable enterprise-level apps. PHP, Laravel, widely used in content-based websites. Ruby, Rails, convention over configuration framework. Go, C#, Rust, also used in high-performance systems. Backend frameworks, Express.js, minimal Node.js web framework. Django, Flask, Python-based frameworks. Spring Boot, Java-based for RESTful APIs. Laravel, elegant PHP framework. Let APIs in communication. REST APIs, standard web APIs over HTTP. GraphQL, query language for APIs. WebSockets, real-time communication, e.g. chats. Number 3, database technologies, data storage. Databases store user data, application content, sessions, etc. Relational databases, SQL, MySQL, PostgreSQL, SQLite, Microsoft SQL Server. Non-relational databases, NoSQL, MongoDB, document-based storage. Redis in-memory data store also used for caching. Cassandra's CouchDB, distributed and scalable DBs. Number 4, DevOps and deployment technologies used to deploy, monitor, and scale the application. Hosting platforms, Vercel, Netlify, for front-end deployment. Heroku, Render, Railway, easy back-end deployments. AWS, GCP, Azure, enterprise-level cloud providers. DigitalOcean, Linode, affordable VPS hosting. CI/CD tools, GitHub Actions, CircleCI, Jenkins, automate builds and deployments. Containerization and orchestration. Docker, containerize apps for consistent environments. Kubernetes, manage containerized applications at scale. Authentication and security. Auth methods, JWT, JSON Web Tokens, token-based auth. OAuth 2, OpenID, for login with Google, Facebook, etc. Session-based auth, traditional login sessions. Security practices. HTTPS, input validation, CSRF XSS protection, rate limiting, course setup. Number 6, additional tools and technologies. Postman, API testing. ESLint, this prettier, code linting and formatting. Figma, Adobe XD, UI UX design tools. Sentry, LogRocket, error monitoring. Hack MERN stack, example of a full stack layer, technology, front-end, React.js, back-end, Node.js plus Express, database, MongoDB. Would you like a visual diagram for this explanation? In a typical full stack application, technologies span across 3 main layers. 1, front-end, client-side. 2, back-end, server-side. 3, database, data storage. Let's break down each of these with detailed explanations and popular technologies.